In continuation of lecture series based on successive differentiation, today we will discuss about the nth derivative of e raised to the power ax sine bx plus c or e raised to the power ax cos bx plus c. So we write down as to find nth derivative of e raised to the power ax sine bx plus c. So first we obtain the nth derivative of e raised to the power ax sine bx plus c, then e raised to the power ax cos bx plus c. So now we write down the let y is equal to e raised to the power ax sine bx plus c. So this is our equation number 1. Okay, so y is a function of x. That means we differentiate 1 with respect to x. So we write down as y1. y1 is equal to. So here we see that there are two functions of x. One is e raised to the power ax, second is sine bx plus c. So we take the rule for differentiation. So first we take as the differentiation of first. The differentiation of first is a into e raised to the power ax. Into second we write as it is. So sine bx plus c plus first function as it is e raised to the power ax into differentiation of second. So cos bx plus c into differentiation of bx plus c is b. Okay, so we write down this as a e raised to the power ax into sine bx plus c plus second we write down as e raised to the power ax into b cos bx plus c. So in next term, we take e raised to the power ax as common. So this we can write as a into sine bx plus c plus b into cos bx plus c. Okay, for making convenient to write the nth derivative of this, we write or put a is equal to r cos theta and b is equal to r sin theta. So here we use the substitution in this step. So we write down as y1 is equal to, or we use this substitution inside the bracket. That means we write down as a, in place of a we write down as r cos theta into sine bx plus c, or for b we write down r sin theta into cos bx plus c. Okay, so here we see that we can take r as common. So when we take r as common, so we write down the e raised to the power ax into r. So this can be written as sine bx plus c into cos theta plus cos bx plus c into sine theta. So you know the formula sine a cos b plus cos a sine b. So this is the sine a plus b. So here we apply the formula sine a cos b plus cos a sine b. This gives us sine a plus b. So we use this formula So we can write e raised to the power ax into r. So this gives us sine a. What is a here? A is bx plus c or b is theta. So we write down a bx plus c plus theta. Bx plus c plus theta. So this is our first derivative. So this is our first derivative. So this is our equation number 2. So here we write down this as. Now, when we obtain the second derivative, that means that is y2. So y2 gives us y2. So y2 similarly, similar we use as e raised to the power ax be one function. Second is sine bxc plus theta. So we write down the first function. So we write a e raised to the power ax into second function remains same sine bx plus c plus theta plus first function as it is and differentiation of second cos bx plus c plus theta into differentiation of bx plus c plus theta gives us b. Okay, so this is the second term. Now we replace a and b as r cos theta and r sin theta. So we write down as r into e raised to the power ax taken as common. So that in place of a, we write down as r cos theta into sine bx plus c plus theta plus in place of b, we put as r cos theta, r sin theta. So r sin theta into cos bx plus c plus theta. Okay, so in this we take as r as common. So we write down as r square into e raised to the power ax. Or again we make a formula in this way. So we write down as sine bx plus c plus theta. So sine a cos b. So cos theta plus cos a sine b. So cos bx plus c plus theta into sine theta. So again we use this formula sine a cos b plus cos a sine b means sine a plus b. So this can be written as r square e raised to the power ax into sine bx plus c plus theta plus theta. Okay, so this is our a and this theta is our b. So this is our a and this is b. So we write down this as so r square e raised to the power ax into sine bx plus c plus 2 theta. Bx plus c plus 2 theta. So similarly, so this is our equation number 3. We do for the third derivative. So similarly, we write down on the basis of first and second derivative. In first derivative, we have e raised to the power ax into r raised to the power 1. And here is r raised to the power 2 in second derivative. And sine bx plus c plus theta. That means coefficient of theta here is 1. But here the coefficient of theta is 2. So similarly, when we write down for third derivative, so this gives us r raised to the power 3, e raised to the power ax sine bx plus c plus 3 theta. Bx plus c plus 3 theta. And we do for the fourth derivative, fifth derivative, and similarly we write down the nth derivative. So the nth derivative, so we write down the yn. Yn is equal to r raised to the power n, e raised to the power ax into sine bx plus c plus n theta. So bx plus c plus n theta. So this is our nth derivative. Now we replace the values of a, that means r and theta. Okay, so we substitute, that means you see that. So here we substitute the value a equal to r cos theta. So now we remember this one. So a is equal to r cos theta and b is equal to r sin theta. Okay, so when we write down this as, so this gives us tan theta. Tan theta, tan theta is equal to b upon a. So tan theta is equal to b upon a. So this gives us theta equal to tan inverse B upon A. So theta is equal to tan inverse B upon A. And the value of R, so that means when we uh, write this as squaring and adding. Squaring and adding. So this is the equation number 1. This is the equation number 2. Squaring and adding both equations. So this gives us uh, a square plus b square is equal to r square cos square theta plus r square sin square theta. So we take r square as common. So cos square theta plus sin square theta. So this is equal to 1. So we write as r square is equal to a square plus b square. So r square is equal to a square plus b square. So we have to remember this one. So the values of r and theta we put in this way. So theta equal to tan inverse b upon a. So here we write down as where theta is equal to tan inverse b upon a, and r square is equal to a square plus b square. So means r gives us a square plus b square raised to the power 1 by 2. So here in terms of AB, so we write down as yn is equal to a square plus b square raised to the power n by 2 e raised to the power ax sine bx plus c plus n theta tan inverse b upon a. So this is our nth derivative of e raised to the power ax sine bx plus c. Okay, so similarly, you can write down for cos ax plus b. So we can write down as, so similarly, there is no need to obtain, or you can do similar fashion. Okay, so similarly, we write the nth derivative. We write the nth derivative of e raised to the power ax cos bx plus c. Okay, so when we write as y equal to e raised to the power ax cos bx plus c. So we write down as cos bx plus c. So this is our equation 1. And similarly, we differentiate 1 with respect to x. So differentiate 1 with respect to x. And we see that y1 is equal to a e raised to the power x. Here is 2 functions of x. So, and the second function same, bx plus c plus e raised to the power ax, or differentiation of cos is minus sine. So we write under c. So here we take the negative sign. Okay. So similarly, we write down y1. So e raised to the power ax taken as common, or in bx plus the differentiation of bx plus c is b. So we write down as a cos bx plus c minus b sine bx plus c. Okay, so again we substitute a equal to r cos theta and b equal to r sin theta. So when we substitute this, so directly we write as y1 is equal to r e raised to the power ax cos bx plus c plus theta. This is our equation number 2. And similarly, we write down the nth derivative. So we write down the nth derivative of this. So we do the directly. So we write down r raised to the power n e raised to the power ax cos bx plus c plus n theta. So this is the nth derivative of e raised to the power ax cos bx plus c. So here we also mention that So where theta is equal to tan inverse b upon a, and r is equal to a square plus b square raised to the power 1/2. Thank you. Hope you understand the nth derivative of e raised to the power ax sin bx plus c and e raised to the power ax cos bx plus c.